Welcome everyone. Nice to have you back here for the next Saturday. We're gonna have a talk about LED strips for everyone. Mitch gonna give that. So, and next week we have Anouk here, also very famous. So if you're interested in workshops and this kind of events, check our agenda and activities, and feel free to be welcome here. So the floor is yours, Mitch.
Great, thanks, Dave. Cool. Has everyone been here before, TkkrLab? Yeah? Cool. So you've all been to hackerspaces. Yeah, I've been going around the world since 2007, helping hackerspaces get going and keep going, and this is just one of hundreds and hundreds around the world, or thousands really. So wherever you go, you can go to a hackerspace and be surrounded by friendly, geeky people. So yeah, I now live in Berlin. I'm a member of 2 hackerspaces, and I came here to share what I know with you all. So, and all of you on the internet, hi. So yeah, this is my real contact info, and feel free for any reason. If you have questions about this workshop or anything else, I'm happy to help if I can. And I'll have all of these slides I'm going to show. I'll give a link at the end where you can download them along with all of the Arduino programs that I'll show you on these. And you'll be able to make your LED strips light up similarly. Well, yours are half meter. So yeah, LED strips are cool. They used to be expensive, but now they're really cheap, and you can order them. Everything's made in China. Even stuff that's assembled in Europe is made in China. All these things are made in China, and you can order them on AliExpress for like a couple of bucks. And so if you want more, you can hook them all up like this and send them all over your room and do all sorts of things. So I'll show you about that in a bit. So LEDs come in lots of colors, and you can buy those. If you buy a bunch of them, they're like 1/8 of a cent each. How many people here already know about electronics? Wow, kinda. Well, I'm going to go over then just the basics of electronics in kind of a fun, simple way, so that you know what's going on here, at least the basics of what is going on. Electronics is pretty much our life now in so many ways, so it's really important that we know about it. And we're going to be playing with LED strips, which of course are electronics, so it's good to know what we're doing. At least a bit. Electronics is named after electrons, these little things that are flying around at the outside of an atom. These are negatively charged particles, and then these positive ones keep them in orbit, kind of like little solar systems. And but in electronics, we use those electrons and we make them go around in circles. And electrons like going around in circles. They love it. That's why they're smiling. And if you have obstacles in their path, then the electrons, as they're going, give energy to those obstacles. And if you pick the obstacles, electronic parts, in the right way, then you have a cool project. And if it's not a cool project, well, try again. So in order to make those electrons go, you've got to push them. And you push them with a power supply. And these are all different kind of power supplies, like the one from our laptops. We can have, like for an old desktop, this is a power supply, what you plug into the wall. And batteries are really good power supplies as well. We can put batteries in a battery pack to make things portable. And these are all different kinds of power supplies to push electrons around so they spin around happily in that circle. And when they're spinning around in a circle, they're called a circuit. You've heard that word before, but that's the technical definition. It's a circle that electrons go around and around and around in. And you push them with a power supply, and the amount of push is volts. That's the amount of push. And it says on the side of like a AA battery, 1.5 V, that's V for volts. That's the amount of push for a AA battery, which we've all seen before. And volts is named after Alexander Volta. He's a dead physicist. We name everything in electronics after dead physicists. He did a lot of cool stuff, but nobody remembers him, but we know volts. Yeah, so you push electrons around with a power supply, in this case, a 1.5 volt AA battery, and depending on the obstacles in the path, then they go at a certain speed. The speed that they go around in is called current, and it's measured in amps. And that's named after André-Marie Ampère, another dead physicist. Okay, so if you push on the electrons with more volts, they go faster. That's more current. It's measured in amps, so that's more amps. So here we have 3 AA batteries in a battery pack. There's some math here. 3 1.5 volt batteries is 4.5. Okay, that's the end of the math for today. But the power supply is on, there's 4.5 volts, so it's 3 times faster than the one with only 1.5 volts. And that's 3 times the current, 3 times the amps. They're still happy though. But the thing is, if they're going too fast, some of these obstacles might have too much energy going into them and they burn up. We usually don't want to do that. And sometimes people say the magic smoke goes away from the part, and we can never put the magic smoke back in the part. So the magic doesn't happen anymore. So we don't want to do that. So quite often in electronics, we want to slow down the electrons. And we do that by putting a part here, which is called a resistor, and it has resistance. And it's kind of like a mud bath. See, there's a happy person in a mud bath. The electrons, when they hit that mud bath, they slow down. And since it's a circle, they all slow down. This is kind of like cars going in a circle in Los Angeles in rush hour. They're bumper to bumper, and if one slows down, the whole highway slows down. Same with this. It doesn't matter if the happy person in a mud bath is here or there or there. It's the same thing. It's the same circuit, the same circle that they spin around in. The happy person in a mud bath is slowing down the electrons the same. It's limiting the current, so we have less amps. It's slowing down. You can put them anywhere. And now you know what took me 4.5 years of university to learn, which is Ohm's Law. Oh yeah, I forgot to say. The happy person in a mud bath is a resistor measured in ohms, named after Georg Ohm. He's, of course, a dead physicist, and we also know Georg for what we now call Ohm's Law. Using all the dead physicists, we have volts and amps and ohms. If you push on the electrons, they move. You push with volts. If you push harder, they go faster. That's current measured in amps, more amps. And if you put resistance in the way, they slow down. That's it. That's the basis of all electronics right there. Thank you, Georg. And here's a little bit more math, actually. Volts equals amps times ohms. So we're not going to have to do that today. And everything I just told you, you don't need to know in order to play with LED strips or lots of electronics. But it's just nice to know what we're doing when we're playing with these things. And there's millions and millions of projects online that you can download. And if you know just some of these basics and a few parts, then you can download those things. And you can just do it like it says on the internet. They may or may not work because the person who put it on the internet may or may not know what they're doing. But you can alter it to make it work better or differently, cooler for you. And you get better at this by playing. That's how we all learn. We play differently as little teeny kids. We learn differently as big kids. But we learn by playing. And hackerspaces are a fantastic place to play. So whenever you want to, you can come here. You know how to get here. Or anywhere else where there's a hackerspace. Yeah, the symbol for resistance, ohms, is this Greek letter omega. And we kind of know what omicron is now. That's the little Greek letter O, but this is the big letter O in Greek. And this is just a funny thing I found on the internet. So, yeah, it's just weird. Resistors, oh, what happened? Resistors look like this. They have big ones and little ones, and they have color codes on them. I won't go into that today, but that's just what resistors look like. If you put a resistor of different values, it slows down the electrons more or less, right? More or less resistance in the way. Many parts, if you hook them up backwards, it will make things not work, and maybe magic smoke goes away, and we don't want to do that. So many parts we must make sure that we connect them in our circuit the correct way. A power supply definitely has a right and a wrong way, and that's why we have two different wires on this particular power supply, red and black. And if you hook it up the correct way, red plus and black minus, then the electrons move in the direction that we want for our circuit. If you hook it up backwards, like I said, some magic smoke might go away and it'll never work again. There's different words for red and black. We often call the red one power or positive plus, sometimes just the how much volts are there. Also VCC, the CC voltage. If you play with electronics, you'll see these things. That's left over from the old days of vacuum tubes, or in English, valves. I have no idea what they're called in Dutch. What?
Buizen.
Buizen? Radiobuizen. Ja. Ich verstehe ein bisschen Deutsch, and das ist, that's somewhat similar. But anyways, black wire is minus negative, 0 volts, but it's usually called ground. And we'll see ground in VCC today, I think, but we're using 5 volts instead of 4.5 volts. But ground, the dead physicists a long time ago had the idea that voltage is kind of like height. If I say that I'm almost 2 meters high, what does that mean? It means 2 meters from the ground. But from here, it's not 2 meters. We need a reference point. And in electronics and in height, we usually use the ground. In electronics, we call the reference ground. Make sense? So GND for short is what we usually see. Resistors, it doesn't matter which way you have them. We're not really going to be playing with resistors today, but I'm going to explain a little bit with resistors. But resistors can go in either way. The happy person in a mud bath is a happy person in a mud bath, slowing down electrons the same whether they're upside down or right side up. It slows down the electrons either way. Here's another part that we won't use this part, the generic part. These are called diodes, but we'll use a special kind of diode, which I'll show you next. A diode lets electrons flow one way, but not the other. So electrons can flow this way, no problem, but not this way. And there's a band on one side to show you the minus side. So these are used a lot in electronics, but what we see lots in our lives is these LEDs. These are light-emitting diodes. So when the current flows, the electrons flow in the way they can flow, the semiconductor, they say it gets excited, yay, excitement. And when it's excited, it emits photons, and they bounce off of our eyeballs, and we perceive light of a particular color, in this case, green. But we can, as I showed you, have lots and lots of colors. So, but it's a diode, so it matters which way you connect it. And in order to show you, there's wires on the part. The short wire is the -1. And on the little teeny LEDs that solder directly to a board, they have a little, usually green dot to show you the minus side. So you have to hook those up correctly. And there are lots of colors, including invisible light, which is what I use for remote controls to turn TVs off, because TVs are incredibly annoying and they need to be off. I could turn this one off actually, but for now I'll leave it on. One thing with LEDs, light emitting diodes, they emit more light if the current is greater, if the electrons are going faster. So if you only have slowly electrons flowing, small amount of current, then it's not so excited, so it doesn't put out so many photons, not so much light. But you put more and more current in, and it gets brighter and brighter and brighter. And if you put too much current through, the magic smoke goes away and it'll never light up again. And that's why we almost always have a resistor in line with one of the leads of our LEDs, so no magic smoke goes away. And we can put the resistor, by the way, here. It doesn't matter because we're going to put a power supply here to make it go around, and here's a picture of a circuit. Usually we use a schematic diagram, which I won't show today, but you can also do it in a picture like this. So it's a battery pack. This one shows 2 AA batteries, and we have a resistor. The plus wire goes through the resistor to the plus long lead, and the minus short lead goes to the black wire minus of our power supply, and the electrons go around and around and around. The current's going through this, exciting it. This looks like a yellow LED, so it'll put out yellow light. And you turn the switch off, and of course, the electrons aren't flowing anymore, so it turns off. Depending on the resistor here, if we have a bigger value of resistor, that will put more resistance to the flow, so the current will be less, the electrons are flowing slower, so this will be dimmer. If we have a lower value resistor, there's less resistance, so the electrons will go faster, more current, more amps, and this gets more excited, more light, more yellow in our lives. All right? So this we do by this circuit, changing the value of the resistor, we can get as bright or dim as we want. That's one way to control the amount of light out of an LED. We're going to do it differently today, which I'll show you, because we don't want to make these get brighter and dimmer. We don't want to be constantly putting resistors in and out. We want it to be controlled by a computer. And resistance normally isn't controlled by a computer chip, microcontroller. But we can do this trick called pulse width modulation, which I'll show you in a bit. But for now, let me just show you these 3 LEDs. These all look exactly the same. There's no color in the plastic. The only way we can tell, since they're not in a bag with a part number, what color they are is to hook them up to a battery. And here's a battery. This is a different kind of battery than the others. It's called a coin cell because it looks kind of like a coin. And one side has a plus sign here. That's the plus side. And the other side is the minus. So here's my LED with a long and a short lead. If I have the short lead minus to the minus side of the battery and the long lead to the plus of the battery, you can see this is a red LED. And I have this other one. It's a green LED. And here's another one. Oh, it's blue. And these are coin cells. They have resistance inside. Not because we want that, we usually don't, but the chemistry involved in creating these at the factory is such that there's internal resistance here, so I don't need a resistor so no magic smoke goes away. There's enough internal resistance here, so I knew that wouldn't break our LED or burn out our LED. If you hook this up backwards, nothing happens. But again, that internal resistance makes sure that nothing bad happens to our part, but I can hook it up correctly and it works again. So that's a real circuit. But if we take red, green, and blue light and mix them together, we get different colors. Green plus red light mixed together makes yellow. Blue and red makes magenta. And then green and blue make sort of aqua color. And you can get all sorts of colors, though, mixing red, green, and blue. And in color theory, they have this color space with red, green, and blue. It's this 3D space, and you can get any color, almost any color that we can perceive. And then you can add white light to it to get pastel-like colors and make it more saturated, taking the white away. And that's what we do in these. And these are, each one of these has a red, a green, and a blue LED inside of it. 3 LEDs in one little package. And in order to get whatever kind of color we want, we mix a particular amount of red and green and blue to get that color. They also make, and these are called RGB LEDs, in English anyways, and they also make RGBW, and W is for white, to get more pastel-y or more saturated colors, more bright colors. But these, the ones we have, are RGB, which are totally cool, so, and they're less expensive. So almost everyone uses just RGB. Again, I just put that in there. We have to hook them up correctly. And these, they're already soldered onto our strips, but we do have to make sure that we hook the power supply correctly. If we hook them up backwards, your RGB LED strip will never work again. So we have to be careful with that. In the case of today, that means putting our jumper wires in the correct place, and I'll show you how to do that in a bit too. We also have bigger RGB LEDs, not the kind like these that solder directly. This one I have, it's already on a board. It's 3 LEDs, R, G, and B, in one little thing. And it looks from a distance the same as those others that I lit up that are just one color. But these really are 3 colors. But they have 4 leads, the plus for the red, the plus for the green, the plus for the blue, plus all of the minuses hooked together in this one wire. So that's already inside of this package. So how do we make this light up? Well, first of all, I'm going to light up just one of these. I don't remember what color this one is, but in order to do that, I'm going to do it with an Arduino board. So I'll go over sort of briefly how the Arduino board works and how to set it up. Some of you have already done this, and some have already your Arduino boards blinking an LED, which is the first thing that everyone needs to do when they get their Arduino. And if you can do that, then you can do pretty much anything. Everything is mostly just a hack of that simplest program, which is making an LED blink. But an Arduino board is really just a computer chip on a board. And this is, the fancy word for this is microcontroller. So it's a complete computer on a chip, and all computers, no matter if they're teeny ones like this, or laptop ones, or big computer ones, all computers do is run a program. It has memory where the program's stored in it, and when you turn the computer on, it runs that program. And it keeps doing that till you turn the power off. This makes it really easy to connect parts through these connectors, to connect parts to its pins. And then the program on these little computer chips, microcontrollers, the program controls those parts. An Arduino board makes it really easy to connect parts to its pins, and it also makes it really easy, it makes it really easy to control those parts with a program that you can put in through a USB connector. And that's really it. Arduino is open source. They encourage everyone in the world to copy it and improve upon it, and millions of people have. So Arduino is really popular. It's been around since like 2000 or maybe even longer. And there's hundreds of thousands, if not millions of projects online that people have created for it. It's open source, so people have copied it, and people have, and that made more Arduinos in the world, which made more people make projects for it, which makes more people want Arduino. And these people have a for-profit company called Arduino, and they make lots of money giving this cool project, sharing it with all of us and the rest of the world. And that's why open source is so cool. I make a living on TV Be Gone, a project of mine to turn annoying TVs off, and it's open source. It took me 1.5 years of my life to get all of the off codes for all of these annoying devices, but no one has to do that again because it's open source, so anyone can download all that and turn off TVs and make the world better for everybody. And open source is great that way. So yeah, Arduino is really cool in a lot of ways because it's open source. Yeah, I already said that. There's lots of different kinds of Arduino boards. There's big ones and little ones, because sometimes you need something that controls things in a small space. And next week, Anouk will be here. She uses smaller ones that fit inside of dresses. It's wearable. And then they also have bigger ones, so it can do more powerful things with a lot more parts. There's more pins. And the idea is to buy the size and the least expensive one that you need in order to do your project. The least expensive one is the one we have, and it's called an Arduino Uno, which is, this is an Arduino clone, a copy of an Arduino Uno. And yeah, and that's only a few bucks on AliExpress. It's kind of amazing. Like I said, there's lots of projects. That's just a screenshot of a few of them. You can download them and just try it and play with it and then learn from it. I give lots of Arduino workshops. That's just one of them. That was the last one before the pandemic in Leipzig, Germany. That was 36C3, Chaos Communications Congress. Anyways, there's lots of cool stuff. Arduino has lots of tutorials on their website, and there's lots of other YouTube ones and all sorts of tutorials online. You can download the software on their website for Windows, Linux, or Mac OS, and they even have it for tablets and other things. So there's bazillions of RGB LED strip projects. I'm just going to show you a few today, but search online and see what you can find and play with it, and I'll give you the links for the ones we'll use today. In order to set up the Arduino, the first thing to do is to download the software, which you've already all done when you got here or before, and then this USB cable connects to the computer. Part of installing the Arduino software is putting a driver on your computer, and a driver is what operating systems need, Mac OS, Windows, or Linux, in order to know how to handle hardware connected to it. In this case, the Arduino, and it communicates, USB is serial, so it communicates serial. So when you plug this in, if the driver is installed correctly, your operating system sees what's called a serial port. And serial port used to be the only way you could communicate with your computer, desktops. But now we have USB is a form of serial, but it converts it into the old form to communicate with our microcontroller here. So yeah, but that's already there if you've installed your software. When you plug it in, your operating system sees a serial port, which is your Arduino. And the Arduino software looks like this when you run it. It's some code in there, and you don't need to know how to program to use Arduino, because it comes with lots of examples, and there's millions of example programs online that anyone can just download and use. If you know some basics of programming, which I'm not really going to get into today, then you can hack on Arduino programs in order to modify them to do what you want. Or you can take part of one and part of another and put them together in your program and do all sorts of amazing things. Anything from flying machines and robots to making an LED blink. So when you first install the Arduino software, the first thing you need to do after you plug the Arduino board in through this USB is tell the software what kind of board you have, what kind of Arduino board. So that's under Tools and then Board. And then you go in there and all of these choices come up. These are the ones that the Arduino Corporation created. And then all the copies are going to be like one of these. So if you have a copy like we have, you know you need to choose Arduino Uno. And depending on your version, it'll say Arduino or Genuino. But Uno is the main word for the boards that we have today. And once you click on that, now this software knows how to deal with your board. Then you have to go to Tools and Port to tell it the serial port name. And usually it will say Uno somewhere in the name. So most people have already done that. And don't worry about doing that right now. I'll go around, and if you're having any trouble, I'll just make sure that you've got this all going. But those two things you've got to do to set up your Arduino software the first time you turn it on, the first time you double click on it. Excuse me. So, and then it remembers that, so you never have to do that again unless you change your board or for whatever reason have a different serial port, which rarely happens. So you do that, and now you have this pretty much blank screen, and you can then put your own code in there. And you do that with opening, file open. But file also has all sorts of examples that the Arduino software comes with. And those are really useful for learning about Arduino programming. And in Arduino, Arduino was created for non-geeky artists. That's the original intent. And so people who aren't very geeky can learn to blink an LED, for instance, very quickly. Less than an hour and a half is what they wanted, and they succeeded. But it's super powerful, so it ended up being something that really geeky people also use, because you can use these to quickly create something really cool. So I use it all the time myself. And I've been playing with electronics and computers since I was 6. So, yeah, let's see. Once you load a program in, and this is one for a music synthesizer that I created, and then I have an Arduino Uno connected to a little keyboard and a speaker and an amplifier and all sorts of code inside of it to make really wonderful noise and music. And I like noise and music. But yeah, my project's called ArduTouch, but it's open source, of course. You can download it. It works on any Arduino Uno. Once the code is in there and your Arduino is connected through the USB, in order to get this code into your Arduino, all you have to do is push this button. And that's called the upload button. And it says upload here when you put your mouse on it. And then it'll go through some stuff. You'll see a progress bar, some text will appear here. And it can take anywhere from a fraction of a second to like a couple minutes. And then this code gets transformed into a form the microcontroller understands and sent to its memory, where it then runs that program. And it stays there. You can then take the Arduino and put it in a drawer without power, and then 5 years later, put power on it, it'll still have that program in there. And it'll keep it until you put a new program in there by loading a program in here, and then clicking the upload button. Oh yeah, and then Arduino, since it was made for non-geeky artists, they changed the name of lots of things. So they don't call this a program, even though it is. They call it a sketch, because artists sketch, they don't program, right? So this is an Arduino sketch. But if you hear Arduino sketch, that's the same as an Arduino program. An Arduino program is an Arduino sketch. So yeah. If you go to File and then Examples, then you get all these categories of different examples, and there's lots of cool stuff there. I'm going to show you now Blink. So a bunch of you have done this already, but I'm going to do that for real now. So, oh yeah, I have this. Well, let me just do this now. So I've already made my Arduino blink. I'm off camera, but my Arduino is blinking, and I'll show you how I make that happen. Where's Blink? Here's Blink. So if you go, like I showed you, Arduino, is that it? Yeah, Blink. So if you go to File, Example, Basics, and then Blink, you get this. And I'll just very quickly go over what's going on here. There's one pin of the microcontroller that is connected to the LED on the board. On your boards, the LED is red. On mine, it's amber, yellow, orange. This here tells the Arduino, the microcontroller, do this, whatever's in here, do this once. That's set up. And then in here, loop. A loop is something that goes over and over and over. So in loop, it just does what's here over and over and over again. So when you first turn power on, it sets up the Arduino. In this case, there's only one line of code. And it does this once, and then it comes down here and does these 4 lines of code over and over and over. This, as this gray line here, dark gray line, it tells you what it does. It initializes a pin that's connected to the built-in LED, and it makes it an output so that that outputs something to the LED to make it turn on and off. And down here, digital write, it sends a high to that pin, which turns the LED on, and it says so in this dark gray comment. Comment is just there for us humans to read and understand. These sort of orange, red, and blue lines, that's the code that gets turned into stuff that gets put in memory in the microcontroller, and the microcontroller understands that, and that's the code that actually executes. But these dark gray or black lines, or light gray, are just for us humans to read. And most of the projects you'll see online have lots of comments so that people who aren't very geeky and are even beginners can read the comments and hopefully understand at least something, hopefully a lot, of what the code does, what the sketch does. In this case, we make a pin that's connected to the built-in LED and output so that we can make it high and low to turn it on and off. But in between turning it on and off, we have to have a delay because microcontrollers go really, really fast. The Arduino microcontroller that we're using now goes 16 million times a second, and that's considered slow, but for us humans, that's super fast. So if we didn't have a delay in between turning it on and off, it would go on for a 16 millionth of a second and then off. And that's too fast for our eyeballs to respond. So here we delay for a second. These are actually milliseconds, a thousandth of a second. So if we have 1,000 thousandths, that's a second. So it goes high, turn the LED on, keep it on for 1 second, and then we make low, turn it off, wait a second before we turn it on again, and it does it over and over again. So I already did that, and a bunch of you have done that. So my Arduino board is blinking on and off, a second on, a second off, second on, second off. But I can change that. I can make it blink 10 times faster. Any idea what to do to make it blink a 1/10 of a second on, a 1/10 of a second off, 1/10 of a second? What do I change on my, let's hack this to be a little different. Yeah, so So the 100 milliseconds would be a tenth of a second. Same here. So I'll just do that. Okay, but this is just text on a screen. That did not change my Arduino microcontroller. You can see it's still blinking the orange light at a second. In order to send that to the microcontroller's memory, where it will then run the code, I've got to press the upload button. So let me do that. And there we go. So my computer has a bunch of stuff, so Java runs slowly, and this Arduino software runs on Java. But you can see the progress bar. Once this starts doing stuff, then it'll go a little bit quicker. This normally happens in about a quarter second, but on my computer it's kind of slow because I have other stuff going on. I should have removed that before the workshop, sorry. So there we go. So now that it got orange, and then it sent it to it, and then it says done. And it also is polite, so it says thank you. And now look at my Arduino board. It's blinking 10 times faster. And I'm going to make this way fast. A tenth of a hundredth of a second on and off. That's actually faster than our eyeballs respond. So let's see what happens when I do that. What do you think will happen? Okay, I changed the text. Now I press the upload button. And it's going to go through its thing again. Hopefully a little faster this time. So it's a 10 milliseconds on, 10 milliseconds off, 10 milliseconds on, 10 milliseconds off. That's super, super fast. Our eyeballs can't respond to it. So it will see the built-in LED as just on. We won't be able to see it go off and on and off and on. That's too fast. So we'll just perceive it as being on, but it's only on for half the time and off for half the time. So our vision system will only see half the amount of light because the average amount of light is on half, off half. So here it is. And I don't know if you can see, I'm going to shake this back and forth. If it were just on, you would see an orange streak. But instead, you can see it pulsing. Right? Can you see it pulsing? Like sort of dots across where I wave it. So I can do that. If I now make this on for only 1 millisecond and then off for 10, it will also look like it's on all the time, but it will be only a tenth the brightness because it's only on for 10% of the time. So let's try that. So take a look at how bright this is now. And after I change this to a 1 and then press the upload button, after my slow Java running computer does its thing, you'll see that it's going to be much dimmer than this. After my computer does its thing, which is going to happen really soon if it cooperates. Maybe. Hopefully. There it goes. Okay, it's done it. Now it says thank you, and now look how dim it is. So this is the way with a computer we can control the brightness of an LED. And it's actually very similar to how I make arbitrary, cool, noisy, or beautiful waveforms to make music or noise with my music synthesizer. Except instead of the signal going into an LED, I feed the signal getting higher and lower at whatever rate I want to get pitches into an amplifier and a speaker. And depending on what node I press on a keyboard, it'll do that faster or slower. So that's how we do this, and that's called pulse width modulation. Oops. Let's go back to here. Yeah, so earlier I showed you we can put more resistance or less resistance to make it brighter or dimmer. But we can also, and that also means that there's less or more current, because the more resistance and less current changes the amount, more resistance or less resistance changes the amount of current through the LED. And that is constant current, but we can also have average current. And this is just a little picture to show you if we have the, as we showed with the Blink program, if it's on and off so fast our eyes can't keep up, then it's on for half the time and off for half the time, so we see half brightness. But if we have on for only a quarter of the time and off for 3/4, then we get like a quarter brightness. But we can have arbitrary arbitrary on-off times, and the on versus off time is called duty cycle. That's a fancy word for it. If it's on all the time, that's 100% on, 100% duty cycle. But we can also have, you know, like 62.347%. You know, we just have to have the on versus off time what we want. We usually don't care about so much accuracy, but for doing audio, we do care. Here's a project where I have waving my hand changes the colors of LEDs. And each one of these is an RGB LED. So that's a kit that I have that was really popular. I think I'm mostly out of those now. And each one of these is an RGB LED, and each one of these has a microcontroller in it to control the RGB LEDs. And let me show you this. I'm going to go back to Blink, and I'm going to reprogram it to do the regular Blink. And once that does it, I'm going to light up this LED rather than the one on the board. So you can see how the Arduino easily connects external parts to its microcontroller after my slow computer does its thing. So while it's doing that, let me show you a picture here. Yeah, so the Arduino is ready, but let me show you a picture where, oops, there it is. These pins have numbers and these connectors have numbers. In order to make this light, I've got to connect the plus long wire of the LED to the same pin that the internal LED, wherever that is on here, is connected to, and that's pin 13 as it turns out. So I'll put the plus wire in here, and then the short wire has to go to the reference, which is ground, which happens to be right next to it. So let me do that. So you can see the orange LED is blinking at 1 second. I'll put in the red LED, as it turns out. So I'm blinking the red LED on and off. Okay, so now I'm going to go back here and choose another program that I already have open. And it's going to, I'm going to put in a different LED. This one is a hack of the Blink program, but it has 3 outputs, one for red, one for green, and one for blue. Right now I only have one blue LED connected, but this does that pulse width modulation thing with making it on and off at different ratios to make each of the red, the green, and the blue different brightnesses at different times. So it mixes together red and green and blue with different intensities to get all sorts of colors. And right now I only have the blue LED connected. So you can see that the blue LED, right now it's just on, but you see it's fading out and it's changing its brightness. I'm going to take the blue LED out and I'm going to connect in this. So I have a wire for the common grounds. And then I also have wires for red, green, and blue, which I'll connect. So let me do that quickly. There's blue is 9. Here we go. So check out this. You can see you can't see individual red and green and blue, but you see the mixed colors as what I created there is different amounts of red, green, and blue, sometimes fading, sometimes blinking hard on off, but it fades in and out or blinks in and out different colors. And that's exactly what we need to do for the LED strip. Each of the red, green, blue RGB LEDs on our LED strip has a microcontroller. And one LED with its microcontroller here is connected to the next RGB LED with a microcontroller, which is connected to the next one, the next one, the next one. And there's some code already written by Adafruit, an open hardware company, that makes it really easy to play with RGB LEDs, so you don't have to figure out all of this low-level stuff. Well, I want this much red and this much blue to make purple, and I want then this much green and this much red to make yellow. You can just use it's called a library, which does all the low-level stuff for you, and then with one line of code, tell it to do what you want. And then you have a whole bunch of those lines, so you can say, oh, I want yellow, now I want blue, now I want blue fading into magenta, etc. So let me show you that. Oh yeah, well actually, let me show you how to hook up your RGB LED strip. So let's get back to here. So you can, in your little box, you have one of these, which is a solderless breadboard. We're not going to use them today, but they're really, really nice. If you have only one LED and you want to make it light up with your Arduino board, you just have to plug it into the Arduino board like I showed you with that LED, the red and the blue. But if you want to hook up lots of different parts to make a more complex circuit, you can learn to use a solderless breadboard and then do all sorts of really, really cool things, even more cool things. But we don't need this today because these RGB LED strips came with a connector that make it so all we need are these jumper wires, and each of you has 3 different colors. It doesn't matter which color you use, but here's the cable that goes to your RGB LED strip, and then there's a connector on the end. And one of them, the top 2, are 5 volts, and then this is called A5, which is the name of one of the pins on your microcontroller, your Arduino board, and then the other is ground, the reference. So you can just put 3 wires into these. And that's what I'm doing here. Now these are kind of loose, so they will fall out if you're not careful. And then these 3 wires go to the connector with the same names on them on your Arduino board. So let me go to that picture again. Here's ground. There's also a ground in these 2 holes. A5 is over here, and 5 volts is over here. So I'm going to connect these up like that. All right, so I have my RGB LED strip connected, but it's not programmed for it yet. So let me go to a sketch that's designed for that. And Adafruit created a sketch called Strand Test. Yeah. Oh, that doesn't come with Arduino. You've got to download that. And I'll show you where I have it. But this is running Strand Test. And this is 120 LEDs. The ones you have are 30 LEDs. So we've got to change num LEDs to 30. It comes, I think it comes with 30. But anyways, if you search for Adafruit NeoPixel, you'll find all sorts of cool stuff, including the library and how to install the library. And I'll show you that afterwards. But I'm going to change this to 30. This is running on my 120 LEDs. Oh yeah, and RGB LED strips, they come in lots of different varieties. You can buy them with any length you want, from 0.5 meter up to 5 meters, and then you can connect them a 5 meter section to another 5 meter section to another 5 meter section. And these kinds make it very easy because there's these connectors. See, this one's lit up, but all these others aren't anymore because I disconnected it. But let me hook it up again. And now it starts working again. The RGB LED strips can have different numbers of LEDs per meter. Anywhere from 15 to 144, I think, is the max. And that depends on, you know, what looks coolest for you and your project. Oh, there were some wooden strips on the table before. Can you grab one of those? Because this is something that's kind of nice. So someone here at TkkrLab made these wooden things for RGB LED strips. Right now you can see these are lots of dots. But if you put these here, it mixes the light together so that it doesn't look like a bunch of dots. It mixes it together to just get a strip of color. So you can do all sorts of things like that. They also make RGB LED strips with different amounts of protection. The ones that we have for our workshop now, just to keep it really inexpensive, are the cheapest ones you can get, and there's no protection. These have some amount of protection, a plastic coating on them. They make some that are absolutely waterproof, so they can be out in super storms and they'll keep working. Of course, it gets more expensive the more protection you have. And if you go to AliExpress, you'll see all sorts of different letter number combinations, which are somewhat standardized for explaining the protection. Anyways, let's put in 30, and then do the upload button. And you already got yours going there, and that's the strand test on a half-meter board strip with 30 LEDs. So it's going to do its slow Java thing here. And that one's working too. You can see that it goes through different stages. It does some pattern for a while, then it switches to another pattern and another pattern. Oh, an error occurred. I must have hit a key or something accidentally. COM7. Oh, I have to this is a different board. I have to tell it, oh no, COM7 should work. Why isn't that working? Maybe it's getting confused with this. Yay. So let's see if it works this time. But while it's doing that, let me show you some stuff here, because this is totally hackable code. Setup is the thing that happens once when you turn the power on, and so you just do these. This sets the brightness. You can make it, it's still not working. You can make this much, much brighter by changing this number all the way up to 255, and then it's way too bright to look at. So I set it to 64 so it's not so it doesn't hurt. And this just sets it up so that when you come down into loop, and loop on this one is the things that happen over and over and over again as long as the power's on. This is really long. It's not really short like it used to be for Blink. This is really long. And there's different sections. So at first, it does all of them red, then all of the LEDs on the strip green, then all of them blue, and this one's commented out, so because we don't have W on our strips. Then what's called theater chase, like on old Kino's movie palaces where they have all the lights going around and around quickly. This does it in white, then red, and then blue. And then it does it in rainbow. So all different colors of the rainbow. And you can go through this and see that it does all these different things. And yeah, actually that's loop. So it does what they call color wipe, meaning all the same color, in this case red. And this is the red value, the blue value, green value, and the blue value. 255 is maximum, and 0 is minimum. So this is maximum red, no green, no blue. This one's no red, max green, no blue, so that's green. And if we did 255, 255, 0, that's max green and red and no blue, that would be yellow. If we have red and blue max, we're mixing just red and blue, we can get different amounts from red through purple. If we mix together red and green at different amounts, we can get anywhere between red, orange, yellow, lime green, and green. And if we do all three of them together, we can get various shades of white getting brighter. And pretty much any color that we can perceive. But the theater chase is that colors following each other. Rainbow is making really cool rainbows like that right now. And Rainbow Cycle is making it move. Theater Chase Rainbow is rainbow colors moving fast. And you can control the speed that the theater thing changes if you look at the code down here for Theater Chase. And like I said, I'm not really going to go over programming today, but play around with these things and see what happens. If it stops working, just go back to what you had before, and if it's all messed up and you forgot what you did before, just download it again. You can't really do anything wrong as long as your wires are connected correctly on your +5 volts ground and A5. If those are hooked correctly to your Arduino, you can't do anything harmful to them. And if you do burn out your little RGB LED strip, it's only a couple bucks. You have to wait another week or two to get it from China, from AliExpress. But yeah, so why isn't this working? Let's see, do I have COM7? I've got, let's see, right, no. Oh yeah, I've got one more slide. Here it is. So, yeah. This is a shortened URL for all the Arduino sketches plus these slides. So if you want to take a picture of that, if you want that, that's it. And again, there's my contact information.
So I think that should we can finish now the official stream then, and yeah, you still welcome to play around. We also have an Arduino workshop. I can point you to that, so you can even do more things with the Arduino.
Great.
So I want to thank Mitch for being here for the presentation and the explanation of the LED strips, and close the live stream now.
Yeah, and I can just go around and answer questions if you have any, and make sure you can do cool things.
Okay.
Okay. Thanks. Yeah. Let me, meanwhile, show you like